Hi everyone, welcome to week 10. We're going to continue working on applications of integrals. We have seen areas under curves, volumes of revolution of solids using two different methods. Now we're going to look at arc length. Okay, so here's the goal. Given any function has shapes with curves, what's the length of this curve? Now the tool we're going to use to achieve our goal is that we know how to find the length of a straight line. If we know the coordinate points x1, y1, x2, y2, the length is given by x2 minus x1 squared plus y2 minus y1 squared. This is a direct application of Pythagoras theorem. Brief sketch. Here, if you form a right angle triangle, this length is x2 minus x1 and the vertical length is y2 minus y1. From there, you can just derive that this length L is this expression. The second tool we're going to use is our standard tool of approximating difficult things with easier things. Now, in this case, we're going to approximate all curves by straight lines, right? Now, again, it's the same idea that if I increase the number of straight lines, then my approximation, as the number of lines increase, the approximation gets better. Okay. A side note here, a bonus question, sort of, you can just email me. What's a polygon with infinite sides? What does it look like? Okay. Now, yeah, so the third tool is we let the number of straight lines go to infinity and we obtain an integral. So here's the work, how to get it. Let's say this is our function f of x. Between points A and B is what we're interested in finding the length. We select endpoints and we connect them with straight lines, right? N plus 1 points so that our index goes from 0 to n, such that these points have the following coordinates. P naught is x naught, y naught, Pn is xn, yn, so on. And this, the distance on the x-axis is fixed. I fixed this to be delta x. Now the total length is going to be, this expression here just means the distance between P0, P1, P1, P2, etc. If I add all of these lengths from 1 to n, and then I let n go to infinity, that's going to be the total length. So let's focus on Pi minus 1, Pi. What is that length? That's the length between these 2 points with the following coordinates. So we already know how to find that distance, and that's given by square root of this term. But what's xi minus 1? That's delta x. And let's call this delta y, which makes it delta x squared plus delta y squared. A factor out of delta x squared, or I divide by delta x squared. The delta x comes out. Now under the limit, what is delta y over delta x? Under the limit, that thing is just a derivative. And the summation becomes an integral, so that arc length can be given by this expression. A to b square root of 1 plus dy over dx squared dx. Let's look at an example. Arc length for this function between these points. So I look at the x coordinate is 1 and 4. So first of all, let's find dy over dx. So this is 2y dy over dx equals 3x squared. So dy over dx equals 3 over 2 x squared over y, which is 3 over 2 x squared over x to the 3 halves, which is 3 over 2 x to the 1 half. Right? This comes from the fact that y squared is x cubed and y is x to the 3 halves. Well, then what is 1 plus dy over dx squared? It's 1 plus 9 over 4x. All right. So our integral now is going from 1 to 4 square root of 1 plus 9 over 4x dx. Now, let's say I don't want to deal with the fractions, so I take the LCM and I end up with 4 plus 9x dx all divided by 2. Now I sub in u equals 4 plus 9x. Du is 9 dx. We have seen integrals of this form. This is a special strategy where you just sub everything as u and things work out. When x is 1, u is 13. When x is 4, u is 40. So 13 to 40, 1/2 outside, root u, and dx is du over 9. So that's 1 over 18, u to the 3/2 times 2/3, 13 to 40. That's 1 over 27. Well, if you cancel these out, 40 to the 3/2 minus 13 to the 3/2. That's going to be your arc length. Find the length of the arc of the parabola y square equals x from 0, 0 to 1, 1. Again, same idea here. 2y dy over dx equals 1. So dy over dx is 1/2 times 1 over y, which is 1 over 2 root x. And that makes 1 plus dy over dx squared, 1 over 4x. Slightly different because now we have an x in the denominator, right? So this is 1 plus 4x over 4x. So integrating this under the square root, 1 plus 4x over 4x dx from 0 to 1, we again use the same strategy of setting u as 1 plus 4x, in which case x is u minus 1 over 4. All right, so du is 4 dx. You can change the limits appropriately. When x is 0, u is 1. When x is 1, u is 5. And this is square root of u over 4x is u minus 1. So u minus 1 actually, let's see. Skip that. It's going to be better to plug u as 4x. Yeah, it's going to be, you're going to make more sense doing that. And then 1 plus 4x is 1 plus u. We'll see why. In this case, the limits are going to be 0 and 4, so that I have 1 plus u over u, and I have a du over 4. Why I did that is if I have two terms in the denominator, I cannot split the fraction. But if I have them in the numerator, I can split them. And I can split them as 0 to 4 square root 1 over u plus 1 du, which is then 1/4. That's u to the negative half, which becomes u to the positive half divided by half plus u from 0 to 4. That's 1/4. 0 makes, so the lower term is just 0. Square root of 4 is 2. 2 times 2 is 4 plus 4. That gives me, that's not right, it gives me 2. So that's going to be the arc length. Now, sometimes you may not want to find the exact length, but you want to find the arc length function, which is you want to find a formula for arc length given a fixed starting point. For example, you say, well, what is the formula for the length of this particular graph if I start from x0, y0, and I have a varying point? What we can do is we use a dummy variable t, and we say f of t is x0 to t, 1 plus f prime x squared dx. Okay, for example, let's say this is my graph. Let's find dy over dx is going to be 2x minus 1 over 8x. Right. And I'm going to have to find 1 plus dy over dx squared, which is 1 plus 2x minus 1 over 8x squared, which is 1 plus 4x squared plus 1 over 64x squared minus 4x. That's going to be a half, which becomes 4x squared plus 1 over 64x squared plus half. I see. Which is going to be 2x plus 1 over 8x squared. So what the nice thing that happened here is this was a 2x minus 1 over 8x squared, which is going to have these terms with a negative half, but adding 1 becomes a positive half, so this is a positive square root now. So the integral just becomes 1 to t. Remember, I have to take the square root, so I'm left with 2x plus 1 over 8x dx, which is x squared plus 1 over 8 ln x from 1 to t, which is t squared plus log of t over 8 minus 1. Now, if I want to find the length for any other point, I just need to plug in the appropriate value for t, and this formula gives me the length. The next video, we're going to look at surface of revolution.